welcome to Make the Grade. My name is Caroline Richardson, and I am here today with Karen Kelly to help you with your homework, if you need help with your homework, or to help you with a concept that you're having trouble with in math, okay? So if you have any math questions, you're working on something and you're stuck, your teacher's not around, obviously, because you're at home right now, or even if you're at school and nobody's around, you can give me a call. The number's going to pop up on the screen, but you can give me a call at 217-2203 and ask your question, or if you have a problem in the book, if we have that book with us, you can just tell us what problem you're working on, or if there's just a concept you don't understand, you just want us to find a problem and work through a few things, we can. Also, throughout the week, you can email me, and there's an email address up there, and I'll put that back up in a second. Here we go. An email address at mathhelp. Let me shift this over. Actually, let me back out a little bit. See if that helps. No? It's not letting me back out too much. All right. So there we go, at mathhelp@wcpss.net. And I would check that throughout the week, and I check it right before I come, so if you have any questions, you can email me there, and I will work on those on the air as well, okay? All right. So to get started today, something that's coming up not this weekend, but next weekend is the SAT. So I thought it might be good if we talked a little bit about the SAT. Now, a couple things. First of all, be sure that you understand how it works with the grading, okay? The multiple choice normally gives you a choice between A through E, okay? If you have no clue how to solve the problem, you need to skip it. You have been conditioned that on the test that if you don't know it, guess, okay? Because if you're going to get it wrong, you might as well guess and hope that you get it right. The problem is that on the SAT, if you guess and get it wrong, you lose 1/4 of a point. So if you just guess on 4 of them and get 4 of them wrong, that's a whole point off your grade, okay? Now, if you skip it and you don't get it, you just decide I'm going to leave it blank, they don't penalize you. Now, that doesn't mean you can answer one question on the test and then skip the rest of it and get 100, okay? It doesn't work that way either. There's going to be a certain percentage of the test that you'll have to take, and I'm not sure that. It depends on how many problems there are, but I would say you'd probably have to take at least 3/4 of the questions would have to be answered, and then if you just skip some completely, they won't penalize you for that. Then there's another element to the test, which is called grid-ins, okay? Grid-ins are like freebies, okay? They don't give you multiple choice, but if you get it right, you get a bonus point, basically. If you get it wrong, they don't penalize you. So whenever you can do the grid-ins, even if you guess, if you run out of time, just go through and put 10 on all of them. I don't know, put something. You won't be penalized if they're wrong, okay? Now, there's some good practice books out there, and I tell you for the math, it's going to start with your basic math, which you're going to be like, oh, of course I can do that. Tell you what, those are some of the hardest problems having to do arithmetic problems. It's really weird. And then it's going to go through Algebra 1. It's going to go through Geometry. Yay, we know how much you love that. And now it's going through Algebra 2. That's one of the changes that they made, I guess, 2 years ago. It's going up through Algebra 2. So if you're just starting Algebra 2, or I guess where we stand in the term, you're not quite finished with Algebra 2, or you haven't even taken it yet, but you want to go ahead and take your SAT, you're going to have to be sure that you do really, really well on the problems that are arithmetic and properties and algebra and geometry. You can get a fantastic score, okay? But you have to be sure that you understand those. The last thing I want to remind you of is that the SAT has 3 types of problems. It has easy, it has medium, and it has hard, okay? And once you start doing the practice test, you'll start picking out some of the easy problems and the medium problems and the hard problems. In fact, there's several books out there. One of the reference books I have here is it Barron? Let me see if this is the one. No, it's not. It's the other one. It's by Kaplan, and I am not an advertiser of any one of these books. These just happen to be ones that I've used in my classroom and I use when I tutor. The Kaplan book, one of the things it does, if you look here on the paper, is that when you do a practice set, not only does it do it from a specific section, so here Chapter 8 is all about powers and roots, but then when you do a practice set, it's just on powers and roots, and it gives you basic questions. You can't really see them, I know, but zoom in a little bit. It gives you medium questions, and then it gives you hard questions. And the reason it does that is that so you can start identifying the problems that cause you stress, okay? You're going to be able to start identifying the problems that are more difficult. And then it divides it up into sections, and a lot of your practice books do this. For example, this one happens to be basic algebra. I know there's one section in here called percents, if you look up at me again, called percents. I know for whatever reason, whenever I do a percent problem, I make careless errors. There's something about a percent problem that throws me. It always has, ever since I can remember. So I would know that that's one of my weaknesses. And what I would recommend is if you go through one of these books, like Kaplan, the other one I have is a Barron's book. It really doesn't matter. But go through one of the ones that have separated out the test into sections like powers and roots and basic algebra and properties and numbers and just exponents or just fraction word problems or just percents, okay? And then as you do those questions, give yourself a score and make a graph of the things that you do well and the things that you don't do well. So that when you get on the SAT, if every time you have a fraction word problem when you practiced it you didn't do well, then maybe that's the one you need to skip and come back to work on later if you have time, okay? You don't have 10 minutes to waste, okay? All right, so there's my soapbox on that. The other last thing, oh, see, I said the last thing, but now I'm back again. This is the other thing. The best way to improve your math score is to drill, drill, drill. You've got to practice. You figure there's an infinite number of numbers out there, which means there's an infinite number of questions they can ask you, okay? There's not a standard set, say, of 100 vocabulary words that you can study, although I would recommend you study your vocabulary words of mathematics. But what's going to happen is that you need to figure out all the different types of problems, and there's a lot of them out there. So we're just going to practice, 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 okay? So let me start with a few practice problems before I start getting calls, and then I'll switch over when I get some calls, okay? All right, let's look at the first one. First one is a multiple choice problem. And zoom, zoom, zoom. I have to shift over. Hold on a second. I'm on wide right now. Trying to make sure that everything's set up right with the Elmo today, guys. I'm as wide as it can go, and I'm shifted over off the screen a little bit. So, all right, I'm going to keep going, and they'll figure it out. And if you hear me stumble over a few things while we're checking this out, we'll work it out. All right, this one says, if 2x plus 3y, whoa, now we're on a boat. If 2x plus 3y squared equals 0, what is the value of 3x plus 2y? All right, as we look at this, for a lot of you, especially if you've gotten through the algebra, for a lot of you, the very first thing that should be running through your mind is, oh, I've got two equations, and if I have two equations, maybe I can do some substitution, or maybe I can do some algebra here to plug one into the other, substitute one into the other. Okay, so let me look at the first one. I have 2x squared plus 3y squared equals 0. So maybe I could bring the 3y over, and I'd have 2x squared equals negative 3y squared. If I try to take the square root, I've got a negative, so that's not going to work. So sometimes, and this is going to happen a lot, which is why I pulled this problem up, sometimes the problem is not really about solving it at all. Sometimes you're going to have to do problems which are just think it out logically. Now, I know that seems peculiar since you're taking a math test, but a lot of problems on the SAT are not about do you know the mathematics, but do you know how to take the test, and can you think through logically the mathematics that are there, all right? So if we look at this one logically, 2x squared plus 3y squared equals 0. What is the value of 3x plus 2y, okay? Looking at this, I need to know what values can x be and what values can y be so that this works out to be 0. Well, think about it. What two numbers can add up to give you 0? Well, opposites. You could have negative 1 plus positive 1. That would give you 0, okay? Well, we've got a problem. Since x has been squared and y has been squared, both of those will be positive. So no matter what we do, both of these values will be positive. So what positive number plus what other positive number will give you 0, since this case isn't going to work? All right, what positive number, well, 1 plus 1 is 2, 2 plus 2 is 4, 0.5 plus 0.5 is 1. The only value that's going to work is 0 plus 0. All right, so that means that 2x squared has to equal 0. You can do it algebraically, or you can just think about it, what's going on there. 2 times what number is going to give you 0? Well, x squared equals 0, so x equals 0, okay? So it turns out that x is 0, and we have 3y squared has to also equal 0, so y equals 0. So x has to equal 0 and y has to equal 0 for those two values to work, okay? There was not a lot of mathematics involved here except your 0 times tables. And when did you learn your 0 times tables? Let's see. Second grade, maybe you learned your 0 times tables? So this problem was all about second grade, wasn't it? Pretty scary. All right, now the key is the problem's not over, okay? The next thing we need to do, that mystery hand is helping us. It's like thing. Okay, so the next thing is, now that we know what x and y is, what is the value of 3x plus 2y. Well, that means what is 3 times 0 plus 2 times 0? Okay. Well, 0 plus 0 is 0. So what is the value? B, 0. Okay. So again, this problem was not about doing algebra, even though it looks like an algebra problem. And I'm going to caution you that every time you or when you have an opportunity and you have a problem, it looks like an algebra problem, step back from it. Maybe you don't have to solve anything at all. Sometimes you just have to manipulate it to make it look like the other value. Okay? Do we need to try to reset the Elmo maybe? All right, we're going to go here. Just look at me for a minute. We're going to turn off. See if we need to reset it in any way. What's happening is you guys aren't seeing the full screen. Oh, now it's mad at me. Hold on. It gets upset like a computer. Okay. All right, there. It's thinking now. I hope. All right, well, that's... Oh, there we go. So I've reset it. Did that help at all? All right, we'll just have to work with it today, guys, and we'll figure it out. I'll just keep checking my screen, okay? All right, so this next problem says, if 6 equals 2x plus 4y, what is the value of x plus 2y? All right, so once again, 6 equals 2x plus 4y. What is the value of x plus 2y? Oops, 4y, okay? All right, I've got two equations. Uh-oh. But I don't know what this one equals, so it's not like you have two equations that you could do substitution with. What you need to do is not, again, don't think of this one so much as algebraic, but what can we do to the first equation so that it looks like this? Oh, that looks like a frowny face. So it looks like the second equation, okay? Well, if you notice x plus 2y, if we put a 2 in front of the x and we multiplied a 2 times the 2y, we'd get the 2 times 4y. As a matter of fact, on this first equation, if we divided the whole thing by 2, 6 divided by 2 is 3, 2 divided by 2 is 1, and 4 divided by 2 is 2. Oh my gosh, look at that. X plus 2y. There's x plus 2y. So what does x plus 2y equal? It equals 3, which is B. This problem was not about solving for x or solving for y. It was solving for a grouping x plus 2y. Okay? So sometimes you have to just manipulate the original problem, or the original equation, let's say, that they give you, and try to manipulate it to start looking like the other one. Don't solve for anything. Just keep working and balancing it out so it looks like the other problem. Okay? All right, great. All right, let's try another one. I have these a couple here. Okay. All right, if 2b equals negative 3, what is the value of 1 minus 4b? All right, so in your head you're thinking, I better solve for b. Well, you can. You can take this initial problem, 2b equals negative 3. We can solve for b by dividing both sides by 2. We get b equals negative 3 halves, okay? And as soon as you see the negative 3 halves, sometimes people are going, oh no. So then you could say, okay, what is the value of 1 minus 4b? So now we know what b is, so 1 minus 4. So I'm going to say 4 over 1 just so I can keep it looking like a fraction, times negative 3 over 2. That's 1 minus a negative 12 over 2, which is 1 plus a positive 6, which is 7. All right, that's one way. I solved for b, and I was able to find it. Now, on this easy problem, this is the other sample I want you to see. If 2b equals negative 3, then what if I took the 2b equals negative 3 and I multiplied everything by 2? You can do that. Algebra, you can do whatever you want as long as you do it to both sides, right? So now I have 4b equals negative 6. Oh, I needed to know what 4b was. What's 1 minus negative 6? 7. Done. Okay? Now, why do I like this method better? Well, first of all, fractions. For whatever reason, I would say half the kids in the world get nervous when they see fractions. You shouldn't get nervous with them, but sometimes you do. Also, the more math you do, the more chance for errors. There was 1, 2, 3, 4, 5, 6, 7 to get to 7 steps to get to this final answer. Over here, there was 1, 2, 3 steps to get to the final answer. Okay? The more math you do, the more chance for error. So again, I want you to kind of change your mindset a little bit and stop, well, not completely stop. If it's the only way you can do it, then that's the way you do it. But sometimes look to see if you can make pieces look like the other parts of the other problem instead of always trying to solve for the variable. Okay? All right. All right, here's one that stumped me, and I had to do it 2 or 3 times, so I was like, oh, I definitely have to share this one with you. A rectangular prism has faces with areas of 6 meters squared, 10 meters squared, and 15 meters squared. What is the volume of the prism? This was a grid-in problem. Okay, now in a grid-in problem, and you definitely need to practice these, when you grid, look at me, when you grid in, what you're going to do is whenever you put in your answer, you're going to shift it as far over to the left as you can. And there's slash marks to represent the fraction. There's decimal points to represent decimals. But I think you only have maybe 4 or 5 little blocks that you can put your answer in. In fact, let me look real quick. Do we have a grid in sheet? Well, we'll look at. I'll look up one of the answers. Here we go. Here's what one of the answer sheet might look like for a grid in. Let me zoom in a little bit. Whoa. Okay. So here you have a grid-in value, which it kind of looks exactly like the bubbles for the SAT, I guess, or for any bubble test you ever take. But notice that, see here, there's a decimal, and then there's a slash, and another decimal. So if you were to put in the fraction 1/2, you would put in 1, you'd bubble in the slash mark right up here, and you'd put in 2, and then you wouldn't put anything at the end. Okay. They also will have it graded in such a way that if the answer is 1/2, you also could put in 0.5. So you would put decimal point, you'd bubble that, and then 0.5. So that you can have multiple answers, possibilities for a grid that equal each other, okay? So be real careful on that. All right, let's look at this problem again. I think I'm going to have to go back wide. There we go. All right. So rectangular prism has faces. Okay, this is a geometry problem. So when you first look at it, a lot of times what people do is they scan the numbers, right? Let's go over to the calculator. Scan my numbers. So volume is length times width times height, so that must mean 6 times 10 times 15. Enter is 900. So I come back over to my grid, and I can put in, with the number 2 pencil, of course, 900. Okay? That's not right. In fact, that's one of the things that when I first looked at it started to mess me up because I got so caught in looking at these numbers and that volume is the 3 numbers times each other. First thing I would do is I would always draw it out. In fact, if in doubt, draw it out. In fact, Ms. Kelly over here taught me that. So let's draw out this prism. It doesn't have to be perfect. Okay? A prism is like a stick of butter. It's the one that I always draw. All right. And it told us that the areas of the faces, the area of the faces, not the dimensions. So this front face has an area of 6 meters squared, okay? And this side wall right here, and it doesn't matter because it's not drawn necessarily correctly. I'm going to say that this side wall has a dimension, has the area of 10 meters squared. And then I'm going to say that the top, which is the third face, has the 15 meters squared, okay? So what we need to do is we have to backtrack a little bit because to find volume is length times width times height. That means we need to go back and find the 3-dimension values of our prism, okay? Not the values of the faces. All right, so if we do that, that means we need to look at 6, and the possible values for 6 can be 1 times 6 or 2 times 3. The possible values that will multiply to give you the area 10 would be 1 times 10 or 2 times 5. And the possible values that will give you the area of 15 would be 1 times 15 or 3 times 5. Okay? So now I have some possible dimensions. Well, the dimensions all have to kind of work together, don't they? Sure do. So you need to find a factor of 6 and a factor of 10 because they share this side. Well, the number that they share is 2. Okay, so the dimension of this side would be 2. All right, so that's gone, which means the other missing side over here would have to be 5, and this other missing side here would have to be 3. And sure enough, if we just look at the top, that would be 3 times 5. 2 times 3 is 6, and 2 times 5 is 10. Now we can answer the question. Length times width times height, okay, the 3 different dimensions. 2 times 3 would be 6 times 5, which would be 30. Very big difference, okay? Take your time to take a second and draw it out and think out the problem. Remember, you're not going to get penalized if this is wrong. If I'd put 900, I wouldn't have been penalized. But once you take a second to look at this, it's an easy problem, and you can get this one right and get that extra point, okay? All right. All right, don't forget to call in. Let me remind you of that number, okay? I know you guys are busy and all kinds of things are going on, but go ahead and take a second. Here's the number, 217-2203. Otherwise, I'm going to do a couple more SAT problems, and then I know that I know a couple of the topics that are going on out there, so we'll do some special triangles and just do some other stuff. We might just stick with SAT all day because it's really important, isn't it? Yep. All right, let's look at this one. If x, or 8x to the 1 power equals 64, what is the value of 3 to the 2x plus 1? Okay. Nowhere in this first problem did we say that these were equal, okay? So we can't do anything in terms of setting these equal. But the key is if we can figure out what the x is in the first equation, then that'll be the x in the second equation, okay? Whenever they give you a problem and there's x throughout a variable throughout the problem, that variable is the same throughout the problem, okay? All right, so we have 8 to the x plus 1 equals 64. And we're trying to figure out what is 3 to the 2x plus 1, okay? All right, so if we look at this, first thing is we need some way for 8 and 64 to communicate. Now, those of you in Algebra 2, you're just getting ready to go into logarithms, and you know that you could probably throw log in front of it and do a lot of other stuff, but instead of using some of those rules of logs, what you want to do really is look at your rules of exponents first, even though we know they're all very much related. Is there a way to get these two numbers to have a common base? Okay, and when I say common base, you got to go back to some of your exponent rules, which were if you have a to the x power, a is the base, and x is the exponent, or the power, right? And then, of course, the number up in front of it, let's just put a 3 there, that's your coefficient, right? So is there any way that we can get 8 and 64 to be the same base? Well, sure. What's another way of representing 64? 8 squared, good. So I have 8x to the 1 equals 8 squared. All right, 8 to the mystery power equals 8 squared. What is the value of the mystery power? Well, it has to be a 2, right? Because these bases are equal. So that means you can do a separate little problem now and say x plus 1 has to equal 2. You can just set the exponents equal to each other. And then we subtract 1 from both sides, so we're left with x equals 1. Okay? So here we go. X equals 1. The answer is A. Nah. Lollipop, lollipop, oh, lollipop, lollipop. Okay? That's what I'm going to affectionately call as a sucker problem, okay? Because you did all this work and you came up with x equals 1, and sure enough, A equals 1 is there, and you're so excited something matched that what did you do? You bubbled it and you're ready to go. Notice also that B is 3, that if you had actually added 1 to 2, you would have gotten 3, and you would have been excited you got that answer, and that would have been wrong as well. All right, so what is the problem here? Well, the problem is that wasn't the question. The question is, what is the value of 3 to the 2x plus 1? Okay? So now we have to go back and say, all right, I know what x is now, so 3, let me shift up a little bit so you can see. 3 to the 2x plus 1, if I know that x is 1, that's 3 to the 2 times 1 plus 1, which is 3 to the 2 plus 1, which is 3 to the third power. Now, 3 times 3 is 9. There's C. Nope. Lollipop, lollipop. They keep getting you, don't they? If you made a mistake with arithmetic, if you bubbled too soon. 3 to the third power is not 9. If you get mixed up, don't be proud, use your calculator. 3 to the third power means 3 times 3 times 3. Not 3 times 3, it's 3 times itself 3 times. That is 27. Ta-da! And then, of course, 81, if you multiplied too many 3s, you would have had 81. Okay, so the answer is 27. This is a great problem. I picked this one specifically because at every possible step you did, it was basically a sucker question all the way along. This math was not challenging, but if you made any careless errors, and you're going to be a little stressed out with the SAT. Look at me. You're going to be a little bit stressed out with the SAT. In fact, the first time you take it, You're going to be really, really nervous. Even though you've done practice problems and you've done practice tests, a lot of times you might be taking it at a school that's not your school. You're going to be sitting in a classroom that's definitely not your classroom. You're going to be sitting around people that you might not know, because there might be people from all over the state, or, I mean, people from all over the world can come take it in North Carolina at, you know, whatever school it's offered. It's going to be at 8 o'clock in the morning, and it's a 6-hour test. Oh my gosh, okay? So you're nervous enough as it is. You're sitting there and you go through it. The first time you go through, just get through the test, okay? The second time you get through, you're not going to be as nervous because you know what it looks like. And you will have gotten back your scores from the first test, and you can take some time to work on your strengths and weaknesses, okay? And then the third time you take it, and yes, I would recommend you take it at least 3 times. The third time you take it, you can home in on strictly the things you're not doing well, and the things that you do well, you know you've got it under control, okay? So you can really home in on it and just raise your score, okay? Each time you take it, hopefully your score will go up a little bit more. In between that time, practice, 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 practice. And there's some good practice programs, I guess, online. And talk to your teachers, because Wake County bought a license to do an SAT prep program online. And you just have to get the code from your school. And you can just go online, and you can even do the essay, and it grades the essay for you right away. It's really awesome, okay? All right, so let's do one more. Let's do a couple more. I don't hear that phone ringing. Come on, everybody. Let's see. Is this an SAT kind?
Yes.
Okay.
Geometry.
Geometry SAT. We love geometry. If I was going to tell you to do something to remember your geometry, look at me. And if I was going to tell you something to pass geometry and do well in geometry, it would be to learn your definitions, yes. And then for the SAT, what I would do is I would go back and find a geometry book, and you can go ask your previous math teacher or math teacher if you can borrow one or check one out, and they can put it in the system, and if you lose it, then you buy it, right? Or, you know, there's some reference books out there, but basically read through your theorems and postulates. Those theorems and postulates were the rules, okay? The rules that you needed to remember. All right, let's look at this problem. Whenever they give you a geometry problem and they give you the picture, please don't count on it being to scale. There's no reason the picture should be to scale. In fact, a lot of times they're going to go out of their way to tell you the picture's not to scale. And when they tell you it's not to scale, that means they're trying to trick you. Excuse me, I was just getting a sip from my Applebee's cup, which, by the way, if you call, look at me. By the way, if you call Applebee's, they'll give you a free dessert. Come on, all you have to do is call and ask for a math problem. Okay. Is the phone plugged in? Are we sure we're on? All right, back to the problem. All right, so looking at this one, this is a triangle. In the figure above, x equals 2z, and y equals 3z. What is the value of z? Okay. Now, we have a couple options here. Since you have a multiple choice, one of the things you can always do is plug and chug, right? So if you put in, let's say, 24, we'll test it out. Let me redraw it just so I don't mess up this one. Let's do a plug and chug with the first one. We'll see if that works. So that means we're going to put 24 in for z. If we put 24 in for z, we know that x equals 2z, which means x would have to equal 48. Okay? And if x equals 48 and z equals 24, then what is the value of y? Well, the x and y are supplementary angles. So we would have to say that y is 180 minus 48, which is 132. All right, well, if that's 132, it also told us that y had to be 3z. So does 132 equal 3 times 24? Let's see. 3 times 24 is, 72. 132 does not equal 72. Okay? So A does not work. That's one way you can approach this problem. The other way you can approach it is you can look at and say, okay, I know that y plus x has to add up to 180. Let's see if that helps me. Y plus x equals 180. And what is the value of y? The value of y is, now we can't solve this one, right, because it has two variables. But look at the values. The value of y is 3z. And the value of x is 2z, which means 3z plus 2z also equals 180. Now we can solve the problem because we only have one variable. So 5z equals 180. Divide that. 180 divided by 5 is 36. Z equals 36. The question was, what is the value of z? There it is, C, okay? So you could have done this one using kind of a plug and chug method if you just want to test all your values. One of them's the answer, and once you find it, you're done. Or you needed to remember a couple basic things, and that is that y plus x are linear pairs, which means they're supplementary. And then you had some basic substitution here, all right? Good problem. Let's look at another one. More geometry. In the figure, AD is parallel to BC. Then x equals what? Okay. All right. Now, you are able to write on the test, right, when you take the SAT. You're also allowed to have several, you can have calculators. I strongly recommend, look at me. I'll make a pretty one. I strongly recommend that you not only bring your handy-dandy graphing calculator, but I would go out to Walmart or Kmart or some store. You can go to the food store now and get a simple calculator that does fractions. Now, I don't have one in front of me. I would have brought it, but there's some simple calculators that have that A/B/C button on it, and they convert fractions and decimals real easy, and percents, things like that. I would get a very basic calculator that would also help you with some of these problems. Line them up in front of you, okay? As long as they're legal, you can use them. All right, the other thing is I would take my pencil on the paper, and let's make sure that we really see what is parallel. In this problem, it told us that AD was parallel to BC. So I don't think you can have a pen on the test, but you can certainly take your pencil and just be sure that you know exactly what is parallel. If it's not drawn to scale, I would redraw it so that they look parallel, okay? Now, as soon as you see parallel lines, first what you need to do is start thinking about your special angles. What are your special angles? Parallel lines. Alternate interior angles are congruent. Alternate exterior angles congruent. Corresponding angles congruent. Same side supplementary, okay? With a big if in front of it is that if lines are parallel, then these things are true, okay? All right, so if we look at our problem, we have parallel lines. Do we have any of those special angles? Okay, well, let's see. I have this transversal right here, okay, AG, that transversal. So let me just kind of cover up everything else. So if AG is a transversal, that angle G is not on the parallel line, so that's not going to help us, okay? I also have this transversal over here, DG, and if DG is a transversal, then do any of those angles work? Okay, well, there's no two angles that are on the parallel line, again, so that's not working for us. And then we have this transversal, and again, there's no two angles. So we need to find a few more angles. Oh, the phone's just been plugged in. You have been calling. All right, so we had a few technical, but we got you. Now you're calling. Thank you. All right, so let's look at this. Can we come up with another value up here? 70 degrees, 60 degrees. We can find this value, okay? So what is that value? Well, we know that all the angles of a triangle add up to 180. So 180 minus 70 minus 60 equals 50. So I know the value of this angle is 50, okay? If the angle of this value is 50, then I can find this value right here, right? Because 180 minus 50 equals 130. All right, so that's 130. What else can we find? Well, we have this transfer. We have to try to get x, right? So we need to find something that will connect these. So let's just keep going. This one's vertical. So that's 50. Oh, and look, we have a 50, a 60. We have another triangle. So 180 minus 50 minus 60 equals 70. Okay? Oh, no, I don't want you to look at me yet. We're teasing. Okay, so that's 70. So now what can we do? Ah, grasshopper. Look, there's the transversal that has the x with it. Okay, so that means we need this angle and this angle. And what type of angles are those? Those are corresponding angles, which means the value of this one is also 70, which would be E. Okay, now look at your possibilities. Look, they gave you C as a possibility is 50, and that was our very first step. We found 50. Again, don't get so excited that you found one of the answers that you stopped the problem, okay? Good problem. And what did you have to remember? You had to remember two basic concepts, or three basic concepts. The sum of the interior angles of a triangle are 180. Linear pairs add up to 180. And that corresponding angles with parallel lines are congruent, okay? All right. So now we have an actual homework problem, I think. It's come in from Southeast Raleigh High School. Liz from Miss Snellgrove's class in Algebra 3 says solve
Okay.
40
And what's
e to the 6x equals 240.
Okay.
Now, e in this case is not representing
And what's your name?
a variable, if I'm not mistaken. E is representing that special variable, kind of like pi, which is what, 2.7. Can't remember it all. That's which is terrible. I should, but it is on your calculator, so we could punch it in. Let me see what e
All
equals
right,
for
so
sure.
could you tell me what your
Well,
homework problem is?
let's go ahead on with the problem. Then I'll solve it, okay? So, but we do want to do it. We want to get e by itself, Liz, okay? So that we can isolate it. And once you've isolated the e, then you can use the natural log to solve for it, okay? So we're going to divide both sides by 40. And we're left with e to the 6x is equal to 240 divided by 40 would be 6, okay? Once you have that, you can remember some of your rules, and that is we can take the natural log of both sides. So the natural log of e to the 6x equals the natural log of 6. Now, using your rules of logs, when it's the exponent, what happens to it?
Hello?
It comes down in front.
Are
And
you
we want to
there?
do that as fast as we can
Okay,
because
did
we're
you
going to
find your
solve for
homework
x. We have to
problem?
kind of get everything on the same level.
What is it?
So bring that 6x over, and we get 6x
Okay.
times the natural log of e equals natural
Okay.
log of 6. All right, how can we get the 6x alone? Well, we'll divide both sides by the natural log of e.
Okay.
Let me bring everything up here a little bit. So
Okay.
we get, did I do that right?
Okay.
Well, I guess you could do that too. We can go ahead and figure out what that is.
Say again.
Natural log of e, let's see. Natural
Okay.
log. No, how am I doing this? I'm not doing this right, am I?
Okay.
Yeah, I want to divide both sides.
I'm sorry.
You're getting me, Liz. It's been a long time. So
Leaders, okay.
6x equals natural log of e
Okay.
divided by the natural log of 6, right?
Okay. Okay.
Gosh, you got me thinking on this one now.
In words.
Let me look at it. Hold on. It's okay.
All right. I think I've got it. Thanks for calling, Anna. We'll
Let
try
me
to get that
see.
in just a minute.
Natural log of e.
And there was more?
Oh, you know what? I think I
Okay.
wrote your problem down wrong, didn't I? It's 0.6. 0.6.
Oh, okay. Go ahead.
0.6, right?
Okay.
All right, that's better. So natural log of e is just 1,
Okay. 725.
right? There we go.
Gotcha.
Because they're inverses of each other. No wonder I kept losing my 0.6 there. Okay. All right, so now we have 0.6x equals the natural log of 6. That's
I'm
much
sorry, say
better.
again?
Divide both sides by,
Okay.
see, there's a rule I had to remember.
Okay.
Okay, they're
2500.
inverses. So divide by 0.6,
Thousands.
and
Okay.
we're left with x is equal to,
Okay.
and we have to go to the calculator for this one.
Okay.
So natural log of 6
Okay.
divided by 0.6
Okay.
equals approximately
All right.
2.9, and I don't know which you had to round these to, so we'll say 2.99. Okay?
Okay.
Whew, good problem. All right, Liz, let's look at
Okay.
the next one.
So,
B. 5, let's make sure you can see. 5 to the
Okay.
4x minus 7 minus 3 equals 10. Okay? Now, this is one of those cases that if you can, you want to
Okay.
try to get common bases. Okay? So first thing we need to do is isolate
okay. Symbol.
the base that has the variable that we're trying to solve. So let's add 3 to both
Mhm.
sides. So we have 5 to the 4x minus 7,
Okay.
or add 3 to both sides, equals 13. All right? Next thing, we need to try to get common bases. Well, 5 and 13 do not have a common base, okay? It's not like you can take
Okay.
32 and say it's 2 to the 5th power, and you can take 4, and which is 2 to the 2 power, okay? So that we can't get common bases. So what you can do is you can take the natural
8,
log
7,
of both of
9.
them.
Okay.
Sorry.
All right.
Natural log of 5 to the 4x minus 7 should equal the natural log of 13, okay? So,
Okay.
again, following our rules of logarithms, we bring that exponent around to the front. So, 4x minus 7 times the natural log of 5 equals the natural log of 13. Divide both sides by the natural log of 5. We're trying to isolate that x now, right? I'm going to come up here. So 4x minus 7 equals the
Okay.
natural log of 13 divided by the natural log of 5, okay? Now, these are things that your calculator can actually do,
Okay. So that's 3 of them, right?
right?
Just 2 problems.
So
Okay.
this is an actual
All
value.
right, I think I've got it. We'll
So
try to get that up,
4x
Anna, before
minus
the
7
show is over. Okay.
Or Add 7 to
Thank
both
you for
sides.
calling.
4x equals
Bye-bye.
the natural log of 13 divided by the natural log of 5 plus 7. And then our final step is we can divide everything by 4. And I'm just going to pop all this into the calculator. Divide everything by 4. So now x equals. Let's go ahead and put this in the calculator. I did that different, I think. I hope I did it right. Let's see. So the natural log of 13. Now you could have done this all the way along. You're going to be able to round numbers. Divided by the natural log of 5 equals, that's this value right here, right? Plus 7. All of that divided by 4 is approximately 2.14, okay? 2.15, I guess we're going to round it to that, okay? Now, you could have done this another way by splitting up what this multiplication means, right? And distributing. So I've separated this one. So if I have time, I'll go back and show you another method to do this. I always treat these just like they're actual numbers. We know they're numbers somewhere along the line, kind of like pi, where you just don't work them out until the very end. Okay? All right, good one. All right, and part C, for this one you need to remember what the definition of a log is. Okay? So the log of some base of a number equals the exponent. It's kind of a way of looking, not e the exponent, which means a base, or the base to that mystery exponent equals the number. Okay, those are the conversions. You have to be sure that you can go back and forth between them. So in this case, we can go ahead and say that 4, the base, raised to the 2 power, should be equal to x plus 3. And that we know how to solve, okay? 4 squared is 16. Make sure I'm on the screen. 16 equals x plus 3. We'll subtract 3 from both sides, and we're left with x equals 13, okay? All right. You've got to be able to do this like the back of your hand. Convert back and forth, back and forth, back and forth, okay? It's kind of like an accordion. Logarithms are a lot like an accordion, which were like radicals and exponents, where you're constantly expanding it and putting it back together, expanding it, putting it back together, until you manipulate it into something that you can work with. Common bases, a simple equation, something like that, okay? But you've got to know those basic rules, okay? And they're all related. Exponents, radicals, and logarithms are all related somehow, okay? I didn't mean to leave that as some mystery. You've learned how, okay? All right. Well, I don't have another call right now, but our phones are working, so you can go ahead and call. What was that number again you asked? Don't feel defeated. 217-2203. That number again is area code 919-217-2203. Thank you. All right, did you like my creepy voice? I'd love to do little voiceovers for stuff. I think that'd be kind of fun. All right, let's look at this one. SAT problem, but this is also very pertinent to what some of you are working on right now. I believe you're working in geometry on special right triangles, your 45, 45, 90, right triangles, all that kind of stuff. So I see some right angles here. So let's see what we can come up with. If AD equals 2CD, so if AD, this value here, equals 2 CDs, and BD, this value right here, equals BC, which equals 6, what is the length of AB? All right, so let's see if we can get some values in here. First of all, let's deal with this one right here. BD equals BC. Okay, so first thing we know now is this isosceles right triangle. Both of them equal 6. This becomes a 45, 45, okay? Which means I'm not even sure if I need this information, but CD, we can find the value of CD by doing Pythagorean theorem, or you can remember your shortcut. Shortcut is in a 45, 45, 90, leg equals leg, and the hypotenuse equals the leg times radical 2. Look, is that the answer we wanted, AB? Well, you know what? Looking at this problem, we have to decide, is this a parallelogram? Okay? If it is a parallelogram, maybe we can use this and transfer this value over. So based on that, is this a parallelogram? Okay, you can't just automatically say they're congruent. If it's a parallelogram, then that means that our alternate interior angles would be congruent. So if BC is parallel to AD, alternate interior angles are congruent, so that's a true statement. So they could be, it could be a parallelogram. All right. the other thing we have to take into consideration is that if AD equals 2CD, okay, so AD equals 2 CDs. So that becomes a problem, 2 times CD. So let's see what this one is. So AD equals 2 times CD, and we know that CD is 6 radical 2, so 2 times that would be 12 radical 2, okay? So now we don't have a 45, 45, 90 anymore. Okay, we did have that 90 there. I'm going to double check my picture though. So it's not a 45, 45, 90. So I'm kind of stumped because I know what my answer should be, but this is not a parallelogram. Where's the picture? Let me double check my picture, the one I wrote down. So I want to make sure I get this right. Because you have to be real careful. If they had drawn this different, this is not a right angle. So why isn't it a parallelogram? See, I would say it's a parallelogram, and I would have guessed A. So let me look at this again. Isn't that terrible? See, here, how long have we been doing math, and you have to pass this for the SAT? All right, let me think about it a second. All right, so we know this. So if this is a right triangle, then we can use Pythagorean theorem. We can use Pythagorean theorem to figure out what AB is. Now I guess we can determine if it was a parallelogram. So 6 squared plus 12 radical 2 squared equals AB squared. Right? Mm-hmm. Okay, so 6 squared is 36 plus 288 equals AB squared, whatever that value may be. So 324 equals AB squared. Take the square root of both sides, we're left with the square root of 324 is 18. So AB equals 18. Yeah. All right, so my question is it looks like a parallelogram because alternate interior angles are congruent, in which case these should be congruent. So now I have a little paradox that I need to think about because using Pythagorean theorem, well, in the picture what I didn't raise, the picture was not drawn to scale. So it is entirely possible that something was tilted, and they're trying to make us look at the parallelogram, okay? But I'm going to have to think about that one. I'm going to have to come back to you on that one on why that's not true, because if alternate interior angles are congruent, then it should be a parallelogram. Or no, then the lines are parallel. Oh, that's why. There, that's exactly why. These two lines are definitely parallel, but it could have been a trapezoid. The shape could have been a trapezoid. In fact, it would have to be at this point. These two sides are parallel, but you need both sides parallel to be a parallelogram. Gosh, it stumped me, didn't it? Okay, so I would have done this. This would have been my lollipop right here because I would have automatically made that assumption. Very bad of me. So these top lines, BC and AD, are parallel because of these alternate interior angles, but that doesn't mean anything about AB and DC being parallel because we don't have any facts to go with on those, okay? Ah, great problem, see? Even however long you've been doing this, sometimes it stumps you. Got to have all those properties straight. And see, I thought I had them straight. I danced those properties for you, didn't I? Opposite sides are parallel. Okay, got to have both of them. Great problem. All right, let's see if we can do another one. And this is for Anna. This is a homework problem for Anna at East Wake Middle. A scientist measured the amount of liquid in a solution to be 0.275 liters. How could the decimal be expressed in words? Okay, so basically, how would we? Well, so now I said 0.275, Anna, and that's very lazy of me in terms of mathematics. Okay, the number decimal point 725. We need to go ahead and read that out as if it was a real decimal. Don't do it lazy by saying 0.725. Okay, we sometimes do that. If I was to actually read this number, we need to remember our place values. So after the decimal, that's the tenths place, okay? So tenths. Then the second one would be the hundredths. So hundredths. Don't think you can see that. Here we go, Anna. Hundredths. It's kind of just like when you go the other direction, but with the TH at the end. And then this third value would be the thousandths place. Thousandths. Okay? So when you read a decimal, you read it based off the last place value. So you read it like a normal number. So how would you read that, Anna? If that was all by itself without a decimal, you would say 725, okay? So you read it just like a normal number, 720, or no and actually, 725, and then you deal with the place value because it's a decimal. So it would be 725 thousandths, okay? The word and is the decimal point. So you don't want to say 725, okay? 725 thousandths. So here we have 725 thousandths, okay? This might also, oops, you can't even read it now. Let me back out a little bit, Anna. There we go. So this might be written out F-I-V-E for the letter 5, and this, you might have the word 7, okay? So 725 thousandths. B wouldn't be right because the and is there. This one would be, if I said 7 and 25 thousandths, that would be 7 and 25 thousandths. So that doesn't match. This one right here says 7 and 25. Oh, this one says thousand. There's no TH there, sorry. So this one is 7.025. I was reading the next problem. 7 and 25,000 isn't a real number if we read it. And then 725, that's the value, that's just numbers without the decimal, so that one wouldn't be right, okay? So your answer is A. So a couple things you had to remember, Anna. One, you have to remember your place values, tenths, hundredths, thousandths. You also have to remember that the decimal point is read as the word and. Okay, oops. That was kind of weird, huh? That's I hit something on my machine. And then when you read a decimal, read it as if the decimal point wasn't there, and then throw in the place value. Okay? All right, good job, Anna. All right, here's another one from Anna. Which symbol could go in the box to make the statement true? All right, so I'm going to read these because we're practicing with our decimals. Let's read this. This one is read 879 thousandths, tens, hundredths, thousandths. So 879 thousandths compared to 89 hundredths. Now, Anna, whenever you compare decimals, you want to be sure they have the same number of numbers. So this has a 0, and there's a value there, the decimal point, place, 2 place. This one has a 3rd place value. We need to put something there. And you're allowed to tack on zeros to the very end of a number behind a decimal anytime you want to, okay? Then, after you've done that, and they have 1, 2, 3, 1, 2, 3, see they're the same? Then what I want you to do is I want you to look at it and see how would those numbers compare if there was no decimal there. Which one is bigger, 879 or 890? Well, 890 is bigger, right? So that's going to be true in the decimal world as well. 879 thousandths or 890 thousandths, okay? So this one would be greater, okay? And be careful with your symbols. You kind of think of this like a... So 879 would be less than 890 thousandths, okay? So I always think of this kind of like an alligator mouth, and the alligator mouth is eating the bigger number, okay? So the tiny part, and then it gets bigger. There you go. All right, so be careful of that. Good job. Thank you, Anna. Call me back if you have something else, okay? All right, let's look at some more SAT problems. All right, here's a circle problem, and this is dealing again with the right triangle because I know that you guys are working on those. So let's see. In the figure, circle O has a circumference of 12 pi. If AB equals 8, what is the length of BC? All right, so we're trying to find the here. Now, be very, very careful. AB is simply, well, it's not a chord, it's just a segment within the circle right now. But it is connected to some other things going on here, okay? So let's see if we can get a few things straight. First of all, the circumference equals 12 pi. What is circumference? Let me shift over a little bit to be sure you all can see everything. What is circumference? Circumference equals, 2 pi r. Is that what I want to do? 2 pi r. So something that we do know is that 12 equals 2 pi r, which means that we could divide both sides by 2 pi, or 2 at least for now. Or, no, let's go by 2 pi. Because see how your answers are in radical form? Which means it's trying to be exact, so we can throw pi in there. So equals, did we get an approximation or we did with pi? Let me see how I can come up with this. So that's left with 6 divided by pi equals radius. Oh, I'm off the screen again. Let me go back out. There we go. How's that? That better? All right. All right, so I know what the radius is. Right now my radius, which is right here, is 6 divided by pi. Okay, which is okay. Unless I missed something. Oh, it's 12 pi. I did. See, that should be 12 pi. So my pi's cancel. Thank goodness, because I was trying to, if that pi was in there, then that's not going to give us a radical answer. So I'll double check. Okay, so the radius equals 6. That's good. So the radius equals 6, and this value right here equals 8. And we're trying to figure out what mystery BC is. Well, you guys look. OC is a radius, so that's 8, or that's 6, because all radii are congruent. So what we really need to do is if we can figure out what the value of OB is, then we can figure out the missing piece BC. Well, can we figure out what OB is? Well, sure, look, we've got a right triangle working here. This is what we have going on. We have 6, 8, and here's OB. Let's just call that X. So if we can figure out what OB is, we can by using Pythagorean theorem. And actually, this is one that you should be able to get faster, but 6 squared plus x squared equals 8 squared. So 36 plus x squared equals 64. So x squared equals, I don't see it, equals 64 minus 36, which is 28. So x equals the square root of 28. Now you always have to be sure that these numbers have broken down as far as possible. So let's break down 28 becomes 7 times 4, which is 2 times 2. So x equals 2 radical 7. So that's where some of these numbers are starting to come up now. All right, so x equals 2 radical 7. So that means OB right here equals 2 radical 7. So the question is, what is BC? Well, let's just pretend OB equaled 2. Then we'd say 6 minus 2, right? And we'd get 4. Okay, well, it equals 2 radical 7. The math hasn't changed, just the numbers are a little uglier. So we would say the value of OC minus the value of OB will give us the value of BC. The value of OC is the entire radius, which is 6, minus the value of OB, which we just found to be 2 radical 7. That equals BC. All right, so is that option up there? 6 minus 2 radical, it's not there. Does that mean we did something wrong? No, look at the types of answers. See how they're factoring out a 2? So our answer is probably there, just that maybe we need to go a little bit deeper. Sometimes you have to factor out the answer. So what do both of these have in common? Well, they both have a 2 in common. So factor out a 2. 2 times what gives you 6? That would be 3 minus, and then 2 goes into 2, or divides into 2, 1. We don't need the 1, radical 7. So the answer would be 2, 3 minus radical 7. Is that choice up there? 2, 3, there it is. Dun, dun. Good problem. Okay, and I almost got myself caught up here because I didn't read careful enough that the circumference was 12 pi. That really would have messed things up if I hadn't been able to eliminate pi. That would have been a much uglier answer. Okay? All right. I think I have time to maybe squeak in one more, or is this a big one? Okay. Okay. Let's look at this one. Okay? All right. Each of the 3 shaded regions above is a semicircle. If AB equals 4, so let me mark some of my values. AB equals 4, and CD equals 2 BCs. So CD equals 2 BC. We're not sure what BC is yet. Oh, wait, I skipped. AB equals 4, we got that. We're not sure what BC is. Oh, here it is, and BC equals 2 ABs. Well, we know AB is 4, so that means BC equals 8. And now we can say CD equals 2 BCs, so 8 times 2 would be 16. Okay? So all of these are representing semicircles. Then the area of the entire shaded region is what? Okay? Well, if these represent semicircles, then that means there's another half of circle we can think about over here. Okay, well, that one wasn't very pretty, was it? So really what we're doing, let's call this, we'll call this circle 1, we'll call this one circle 2, and we'll call this circle 3, okay? So really you're going to take the area of circle 1, the whole area, but then you're going to cut it in half. And add that to the area of circle 2 and cut that in half. And then find the area of circle 3 and cut that in half. And that will be the area of the shaded part that's there. All right, so what is the formula for area? The formula for area is pi r squared. So we'll do that in all cases, which means we need to be sure that we know what the radius is. Be very, very careful. Because you have these 4, this 8, and the 16, you're going to get, sometimes you'll get sucked in a little bit. Those sucker problems, you need to be sure you identify what your radiuses are. So radius is 2, radius is 4, radius is 8. Okay? All right, so on the first one, area of the first circle would be pi r squared, which would be 2 squared pi divided by 2, which is, oops, it will go down, which is 4 pi divided by 2, which is 2 pi, plus the area of the second one would be 4 squared pi divided by 2, which is 16 pi divided by 2, which would be 8 pi, plus the area of the third one would be 8 squared pi divided by 2, which would be 64 pi divided by 2, which is 42 pi. So we add all those together, 32. So 2 plus 8 is 10, plus 32 is 42 pi. Look up here, 42 pi, okay? And I bet if you go back on these other answers, I bet one of these other answers is if you'd use the radius to be 4, 8, and 16. So I won't have time to test that because we are out of time, okay? Thank you for your calls. I'm sorry that the phone wasn't plugged in initially, so that's why I was teasing you that nobody was calling me, but you really were, and thank you so much. So I will see you next Wednesday. Get your problems together, email me. Your teacher should be getting a problem of the week sometime this week, and I'm going to have a little competition between the classes on who can call in with some answers, okay? So let me remind you, again, the phone number I gave you, but let me remind you the web address is mathhelp. There we go. Let me zoom out a little bit. mathhelp@wcpss.net. So if you have any questions, you can email me or give me a call next Wednesday, same time, same bat channel, and I'll see you then. All right, have a great night. Bye.